is our student Dia. So this summer, Dia worked on a smart walking stick to aid the visually impaired. And one interesting thing that we all found when working with Dia was that she was always really ready to tackle any new obstacles. She had never worked with Arduino or CAD before, and I would have never guessed that because she was always like tinkering with something, always looking something up online, and I would have never thought that she'd never worked with these components. And I remember this one particular day that she came to Blue Stem really tired after swim practice. I have no idea how she did Blue Stem after doing swim, but she came to Blue Stem and then she's like, oh, I want to make a case for my stick. And then in one day, she learned all the basics of CAD, no experience before. She took a lot less time than I did, and she's in middle school. So it was really impressive, and she made a really cool box. I'm really excited for you guys to see her finished project. So here's Leah.
Hi, I'm Dia, and I go to Bret Harte Middle School, and my project was the Smart Walking Stick. I chose this project because it's a helpful accessibility tool to aid the visually impaired, and I wanted to build a project that could have a positive impact on people. So my project, the way it works, it's basically centered around my ultrasonic sensor, which works by emitting high-frequency sound waves that bounce off of an object and are received by it, and the time it takes for the sound wave to bounce back is used to calculate the distance of an object. So for my project, I use a threshold value of 50 centimeters away or less, meaning that when an object was this distance away, the user would be alerted by a buzzer and a vibration motor that I put by the handle. In the original project, there was no way to stop the buzzer from going off when the ultrasonic sensor detected an object, but this could get really annoying, especially when I didn't want the buzzer to go off when I didn't need it to. And to stop it, I would have to go and unplug the battery, which is really inconvenient. So a modification I added was an on and off switch, which would just allow me to toggle the switch to off and stop the buzzer from going off. The other modification I added was varying the rate of the buzzer based on how far away an object was. So the closer the object, the faster the rate of the buzzing. So here's a demonstration of my project. So I turn it on up here, and my hand is pretty far away from the object, and the buzzer is going off at a slow rate, and the closer I bring it, the faster the rate. And the vibration motor, though you can't see it, is vibrating over here. And then I just turn it off by switching it to off. Probably one of the biggest challenges I faced with this project was 3D printing this box to hold all my components, because I was pretty familiar with all the other aspects of my project, but I had never done CAD before. So it was a big learning process, but I learned a lot of very helpful skills, and something especially that helped me was using parameters, because the first couple of drafts of this box was too small to hold all my components, but all I had to do was change the value of the parameters and make all the dimensions bigger. And I also learned that when a 3D printed object breaks, it's really hard to glue it back together, and that took a lot of patience and time. But overall, throughout the program, I learned that apart from all the hardware skills and soldering, which is very important, I learned that you just have to be really patient with your project, because things are going to go wrong a lot of the time, but you have to just be able to work through it. If I had more time and like in the future next steps, I would probably want to 3D print some sort of casing around the wires so it could be more hardy, and not have all the wiring exposed, and probably add another ultrasonic sensor to have more like range of viewing. But overall, I had a really good experience. So yeah, thank you.
You said the threshold was 50 centimeters?
Yeah.
How did you decide on that, or was it just arbitrary?
It was just trial and error, because I didn't want it to be too far out, so it would go off where there's like no need for it to. But then if it was too close, then it would just be constantly.
How did you connect all of the electronics and that case to the walking stick?
So to connect all my like wiring pieces, I soldered them onto a circuit board, and to connect my box to the walking stick, which you can see took a lot of awkward to get back onto my box because it broke off.
If you add an AI camera, this will also calculate the personal object.
Yeah, that could definitely be something I could take.
Have you ever thought about making like an extendable or like buying an extendable walking stick for like
Oh,
taller
it
people?
does.
Oh, okay.
Do you know why you wanted like to adopt Tabata? Like, what's the
Oh,
feel of the?
Oh, I wound it up on the top because I have a vibration motor here under.
No, not the sensor themselves.
Like,
Yeah. Why are they adopting this one?
because most objects like people walking would like be around this area. If I had it too low, then it would miss objects that were higher. So I put it like around kind of the middle.
What was your favorite part of working on the project? Was it like designing the box